This is Elaine McCormick for our final lab of Physics 1. I looked at a fan cart in motion, and I'm in lab section MO1. So what I actually did for this lab was I looked at the problem, how does the force from a fan cart affect velocity and momentum? I got a video of a fan cart offline, and I looked at how the effect of the force of the fan actually changes the motion and the velocity over a short period of time and a significant period of time. I used Newton's second law, force equals mass times acceleration, and was able to analyze my video that I found in Tracker and then create a model in VPython, which ultimately gave me the final velocity and momentum. So let's first take a look at my Tracker video, which I have here. I set my axis on the fan cart so that it is at 0 and moves only in the positive x direction. And since I got this video offline, I had to use my resources. So the calibration stick is set to an eraser in the background because I was able to measure the actual length of that. And then they had the measurements for the mass of the fan cart and the force from the fan on the website. So I was able to use that when I created my model. So you can see here that I tracked the center of mass as it moves, and the only force acting on it in the x direction is the force due to the fan. So then I took this data, and I have my x data and my time data, and I was able to use force equals mass times acceleration so that the change in position over the change in time gives me my velocity at any point. So if we want to look at the original calculations from my video, I use my x and t data, and I found my final velocity, which was 0.7727 meters per second, and then my final momentum, which is just the final velocity times the mass, and that's 0.803 kilograms times meters per second. So my goal was to create a model that accurately represented this data, and so my initial conditions that I used in my model were the mass of the cart, which I got from the website, which was 0.2334 kilograms, initial velocity, which is at 0, you saw in the video, is at rest, and then it starts moving. That's why you can see it starts slowly increasing, which is the acceleration, which ultimately leads us to our final velocity. The fan force, which was just an average calculation since the force was constant, so it's 0.245 Newton meters, and then my time in my video, which was 3 seconds, like approximately. So let's go look at my model, which I created in VPython. So here's my code. I just updated the velocity and position throughout a while loop of my time, which is about 3 seconds. And then I printed the final velocity and the final momentum. So you can see this running. And what we're going to see in this lab is that initially there's no forces acting on my object. It's at rest. Then we have the fan force. And so it slowly increases speed and gradually builds to a final velocity. This occurs because it's a constant force acting on the object and is continually adding to the velocity. So our velocity equation was velocity equals the current velocity plus the force times delta t. So that's how it continually gets bigger, and you can kind of see that it gradually increases at the end because it was moving real slow at the beginning there. So then if we want to look at the values, I calculated from the VPython model that the final velocity is 0.769 and the final momentum is 0.179. So this is really close to my actual calculations from my Tracker video. So if you look here, here, you can see that it's about 0.01 off, a little, give or take a little bit. So this shows the different ways that I was able to calculate the final velocity and final momentum and how they compare when using the model. So my final results of this lab was that applying a constant force to an object over time creates acceleration. We used Newton's second law, force equals mass times acceleration, to analyze the force on my cart as well as the final velocity and final momentum. Overall, I was able to create a pretty accurate model using VPython, except for there was a little bit of error based on the fact that it was an estimation of force and that we didn't account for all real life forces. So that's my lab.